Okay, area. So the area of a circle is pi times your radius squared. A lot of people lose track of which formula is which for circles. So just remember that squaring is always a two-dimensional concept. It's a flat surface area. And so this formula has the power of 2 in it, which should remind you that it's a surface area concept. Now we will extend that sort of concept to finding the areas of a wedge. Now a wedge is basically just a part of a circle, so when we're trying to find the area of that, we will use the formula for the area of a whole circle, and then just scale it down by timesing it by the fraction of the circle we have. So basically I'm going pi times radius squared. Don't forget there is implicitly a little times sign in here, we don't tend to record it. And then we're timesing that by the fraction of the circle that we have, which is basically the angle of the circle divided by 360, which would be a full circle. So that gives you what fraction of the circle you've got. So let's have a go at a few of these. We'll ignore the trapezium because we did one in the last video. So for this first one, to get the area, we'll be going pi times my radius squared. Pi, of course, is just a number, which is 3.14 yada yada yada. There's a little button on your calculator to get pi. So here we're going to go pi times my radius is 4, so pi times 4 squared, and that would give me an answer of 50.265 centimetres squared. Because I'm measuring in centimetres, those decimals really mean millimetres. So if you're an ATAR student, you should probably do some logical rounding. This differentiates A students from Bs and Cs. I would want to round to 1 decimal place. To do that, I check the second decimal place. If it's 5 or more, then I round my answer up. If it's 4 or less, I'd leave it the same. So in this case, because it's more than 5, I'd be rounding this answer up to 50.3. And that would become my answer. Don't forget your units, centimetres squared. That would be my complete answer for this question. In the next question, they've tried to trick you by giving you the diameter instead of the radius. So look for those things. The formula includes only the radius, and the radius, of course, is half of the diameter. So in this case, my radius would be 4.5 metres. And so my area for this one would be equal to pi times my radius, which is 4.5 squared. Must square it. And when you do that, you'll wind up with an answer of 63.617 metres squared. And again, you know, as an extension here, if you were an ATAR student, if you're measuring in metres, those decimals mean centimetres. So it would make sense to take those out to 2 decimal places. So again, if I was looking at this, I'm going to stop at my second decimal. And so what I'm looking for, I'm just going to make that a bit skinnier. So what I need to check is my third decimal to see whether that one will stay the same or bump up. Now, because the next number is more than 5, I would round this up. So my final answer here would be 63.62 metres squared. In the next one, you're going to do the same thing. Again, they've tried to trick you by giving you the diameter instead of the radius. So you can see here, if you halved 6, you'd get 3. If you halved 8, you'd get 4. So the diameter is 3.4 metres. That's the measurement you need to use. And of course, they've only given you half of a circle. So you're going to need to halve your circle answer. So pi times your radius, which is 3.4 metres squared, that would give you the full circle. And then dividing it by 2 will give you half of the circle. So in this case, when we do that, we would have wound up with 18.2 centimetres squared. Okay. The next one's a wedge. So it's the same sort of process, but now you're going to times, and there's a couple of them actually, now you're going to times your area of the circle by the degrees on 360 to scale it down to what fraction of the circle you have. So here again, area of any circle is equal to pi times your radius squared. So in this case, pi times 3 squared. That would give me the full circle, which I don't have. I've only got a part of the circle. So I then times it by the fraction of the circle I have, which is 41 degrees out of 360 degrees in a full circle. And if we processed that, we'd get an answer of 3.22 centimetres squared. Okay, And again, that means that my decimals are millimetres, so I could round that down to a 1 decimal place of 3.2 centimetres squared. Same process for the rest of these. You're going to do your area is going to be equal to pi times your radius, which in this case is 2 millimetres squared. That would give me a full circle, so I'm going to times it by what fraction of a circle I have, which is 105 out of 360 degrees. Oopsies. So here we go. Oops. So 105 out of 360 degrees. And same for the next one. Only they're trying to trick you here. What they've given you is the 50 degrees for this little wedge, and what you need is the shaded area. So to get your angle, you would go 360, take away that 50, which would give you an angle of 310 degrees. And that's the angle you need to use in that calculation. So here we'd have an area is equal to pi times our radius of 5.1 squared, and then timesing it by the fraction of the circle that we have, which is the 310 out of 360 in the shaded zone. And if you process that, you'll get the answer there. Okay, what have we got next? Kites. We don't tend to do a lot of kites, but if you do see them anywhere, basically to get the area of a kite, you need to find the length of the kite and the width of the kite. We call those x and y, and it's basically a half times x times y. You're basically finding the area of two triangles there, hence the half, and that will work there. Okay. Surface area is an extension of the area concept. Surface area is just applying surface area is basically a three-dimensional shape. So instead of just having to find one area, you're having to find the area of every single face in that object. Now it's basically the area of the shape if we were to flatten it out and turn it into a net. And the net is just that flattened shape. So if we're looking at a cylinder, that's one of our common shapes. The cylinder is made up of two areas basically. We've got the circles, so you can see here I've got a circle at the top and a circle on the bottom. So the first part of the formula that I've got here is 2 times pi times r squared. This whole section here is basically my circles. Pi r squared is a circle. So I'm going to write that on your note. You need to understand what each part of this formula is, because often they'll give you a cylinder which might be a water trough, so it might be open at one end, and you won't have two circles, you'll only have one circle. Or it might be a tube, so it might have no ends, and in that case you've got no circles, so this whole part of the formula would be left out. So the pi r squared, we should know by now, is our circle. The 2 is because we currently had two circles. So if I don't have two circles, then I would adapt that. So one circle, 1 if open, I'll put, and 0 for tube. So you're going to need to adapt this formula depending on what shapes you actually have and whether those things actually exist. The second part of this formula is basically the walls of the cylinder. So if I was to make a net out of this cylinder, I'd basically have two circles, the top and the bottom, and then the walls of this shape. If you got this cylinder and you sliced it down the middle and then you opened it up, then basically you'd wind up with a rectangle, and that rectangle is basically the length across the top is basically the circumference, because we know that basically we're just cutting that circle and pulling it out, stretching it out long. So the circumference is the top bit, and then the height here of that square would be there. So 2 pi r, that part of the equation is the circumference, and then h of course is the height of the shape. So understand your formula and then you can apply it, and we'll go through that now so that you can see what I mean. So in this first question we said it's a solid, and so we have both the circles top and bottom, and we've got the walls of this shape. So to get the area here, I'll call it SA for surface area. I am going to go 2 because I've got the two circles, so 2 times pi times the radius, which they've told me is 3 squared, plus I've got the walls of this cylinder, which is going to be 2 times pi times r, which is 3. That bit there gives me the circumference of the shape, timesing that by 8, which is the height, and together those two things would be the surface area of this shape, which would give me an answer of 207.345 centimetres squared. The decimals here again mean millimetres effectively, so I'd probably round that to 1 decimal place, which means I'm checking the second one. As it's less than 5, that 3 will not be rounded up, it would stay the same. So I'd wind up with a final answer of 207.3 centimetres squared. Now in my next shape, it says that there's no top. So this would be like our water trough that we have around a farm. The top's obviously open so the animals can drink. And so if I was going to do this shape, when I would adapt that formula. So instead of 2 pi r squared, I'm just going to have one circle, so 1 pi r squared. You don't need the 1, you can put it in there if you please. So 1 times, and again, they've tried to trick you here. They've given you the diameter, so don't forget that you need just the radius, which is half of that. So that'll be 6 centimetres. So pi times the radius, which is 6 squared. That's the circle on the bottom of this shape. Plus you've got the walls. So we still need to do the 2 times pi times your radius. That 2 there is just 2 times r gives me the diameter, and this whole bit here gives me the circumference basically. I will just take that r off. We know the radius here was 6. So 2 times pi times 6, not squared because that's just your circumference, that's the linear measure, times the height of the shape, which is also a 6 in this particular question. So once you process that, you would have got a surface area of 226.19 centimetres. And I might round that again to 1 decimal place because that's millimetres, so 226.2 centimetres. Okay. In the next one, again, it says it's a solid, so same process as the first one. This measurement here is 5, and again, they've tried to trick you by giving you the full diameter. So the radius will be half of 5, so 5 divided by 2, which is 2.5 centimetres. And your surface area is going to be equal to 2, because I've got 2 circles, so 2 times the circle formula, which is pi times my radius, 2.5 squared. That's the circles on either end, plus my wall, which is 2 times pi times my radius times the height, which in this case we've sort of tipped that shape over, but the length of that shape is 10. So again, I would pop that in, and that would give me an answer of 196.3 centimetres squared. And that will bring us to cones. Now, in a cone, we've got the circle on the top, but again, you need to be careful because in some cases that circle doesn't exist. If this was an ice cream cone, then there is no surface on the top, it's only the walls that we count. So we need to make sure we understand what each part of this formula is doing. So the first part of this formula is the circle. So if it doesn't exist, you'll need to get rid of that and not use that part. Your radius is self-explanatory. S is that slope on the side, and I've shown that over here. That's my side here. Sorry, that is very thin, isn't it? So there we go. Let's have a look at that. So that would be that side there. That's the measurement that we're using for the slope. And this whole second part together is basically giving us the walls of the cone. So let's do an example. Again, as usual, they're always out to trick you. So they've given you the diameter, but you only need a radius in all these questions. So you'd make sure that you do turn that to a radius. And then when you want to do the surface area, your surface area is equal to pi times your radius, which in this case is 5 squared. That's your circle on the bottom, plus pi times your radius, which is 5, times your s, which is your slant, which is 14. So my formula, I should have written it and then showed the substitution. So pi times r squared plus pi times my radius times my slant. And I've substituted all those numbers in, and what you would have got there is 298.45 centimetres squared. Now in the next one, same sort of thing. Again, they've tried to trick you. They've given you the diameter, not the radius. So if you halved that, you'd have 4.5 metres. Your surface area would be equal to pi times your radius squared to get your circle. So that's pi times, and my pencil's died, so I'm just going to talk you through that one. So pi times your 4.5 squared plus your walls, and your walls are pi times your radius, which is 4.5, times your 6.7, which is your slant. And I'll have to do the next one on another video.